All right, folks, welcome to our webinar on IR automation with LimaCharlie. I'm going to be your host today, Eric Capuano. As some of you may know, I've got quite an extensive background in security operations, digital forensics, and incident response. And that's one of the great things that I get to bring into my work here at LimaCharlie is thinking about ways to push the platform further in the areas of digital forensics and incident response. Because one of the things that I've encountered time and time again in my experience in IR is there's plenty of tools out there to get the job done. The problem is scaling the use of those tools when you're walking into large intrusions that involve many different systems, right? Being able to scale not only the software capability, but also the processing power that's required in order to churn through many gigabytes of digital forensic evidence in order to really get the thing that I need most, which is very detailed chronological timelines of the activities that unfolded on the systems that are in scope of an intrusion. Now, for some of you that maybe have followed my work in the past, you might know that back in, I want to say 2021, Whitney Champion and I gave a talk at the SANS Thiefer Summit on a pretty cool way that we had innovated to do this somewhat at scale. And it was great because it was nice, it was automated, but here's the catch. It still required a lot of infrastructure in order to make it work, right? So you're hosting big, heavy cloud systems, and you're paying for a lot of compute power in order to generate the timelines and the forensic analysis outputs that you need. Well, what I'm really excited to share with you today is that starting right now on LimaCharlie, you can recreate one of the fastest, most scalable, and most powerful incident response and digital forensics processes that I've ever used, and it's all available to you right within our platform. So I'm going to step through a bunch of cool things here today on this webinar, and then I'm also going to share with you a blog post that went live right around the time this webinar started, which is going to go into a little bit more detail and include literally a copy-pastable template. You can paste right into your LimaCharlie organization and instantly recreate everything you're about to see me do here. So really exciting stuff, folks. Thank you for tuning in. Let me go ahead and bring up a screen share and show you around some of the cool new features that we have in store. So the first thing that I'd like to show you is kind of a high-level overview of this process and this workflow. And I'm going to introduce a couple of new tools in the form of extensions here in the platform. But I think it's really useful to kind of level set here and say, okay, what is it we're trying to accomplish, right? Well, let's start with the problem. The problem is, as an incident response consultant, most often I'm going to drop into an organization I've probably never seen before, right? I've never been here. I don't have systems in their environment. And really what I want to be able to do is just simply give them an agent. Here, install this agent and put it across the entire environment, right? Whether that's through GPO or SCCM or whatever configuration management tool you have. That's all I want the customer to have to do. But then I need the ability through that agent to perform not only the from this point forward detection capabilities, which we already have. As you know, we are an EDR agent streaming real-time telemetry. So that's going to give me instant visibility of what happens from that point forward. However, there's a huge missing gap now of, well, what happened before I arrived? As the incident responder, I also need to know what happened yesterday, last week, last month, right? However far back this intrusion may go, I now need to get that historical visibility, which is very difficult to do because EDR, no matter what EDR tool you like to use, it only can see what was happening from the moment that sensor was installed. So I need to get that historical evidence, right? So as an incident responder, I want to make sure that the tool I'm going to deploy not only gives me that forward-looking visibility, but also gives me the ability to reach backwards in time, pull the historical evidence off of that system, and huge bonus, if it can also handle the processing of that evidence, right? Because that's the next trick, right? We're not talking about just pulling event logs and then manually sifting through them. No, I'm talking about pulling all of those valuable forensic artifacts from registry hives to event logs to evidence of execution, prefetch, you name it. We're going to pull all that stuff off these systems. We're going to pull it into the LimaCharlie cloud, and we're going to push it through an automated processing pipeline where all I need to worry about is that on the other end are going to be forensic timelines ready for analysis. this is the thing I get most excited about. So as you can see here on this little diagram I've sketched, kind of showing you just a high level view of what this looks like, right? So notice I've got some endpoints over here on the left-hand side, and that could be one endpoint, that could be 100 endpoints. It doesn't matter. Our platform will scale with you, right? So I've got a series of endpoints that are, let's say, deemed compromised. The thing that I need to do next is I'm going to run a Velociraptor triage acquisition on those endpoints. Now, for anyone that's not familiar with the term, a triage acquisition simply says, go get the best forensic juicy artifacts that you can off of that machine and upload them to me, right? So that's what we're going to do with a triage acquisition, right? We're going to leverage Velociraptor to perform that. But where the magic comes into play is those systems each are probably going to upload a 1, 2, 3, 4 gig, maybe bigger triage acquisition. It's going to upload those into LimaCharlie, and through our detection and response engine, which let me also remind those of you that may not know, not just for detecting threats, but also able to just simply automate activities within the platform. So basically, it's an automation engine at its core. So we're going to use the DNR automation capability to watch for those Velociraptor acquisitions to be completed, and then we're just going to automatically route them to the tools that are going to do the processing of the raw evidence, right? So I'm going to introduce a couple of tools you may be familiar with, you may not be, but I'm going to tell you, in my experience, these are just two of the most powerful tools you could leverage in an incident response. And the bonus is all three of these, Velociraptor, Hayabusa, and Plaso, are open source. Huge fans of open source tools, especially when their capabilities can rival any commercial off-the-shelf tool that's on the market. So big fan of that for many reasons. So we're going to push those triage acquisitions into Hayabusa as well as Plaso, and then out on the other side simply pops forensic timelines ready for your analysis. And I'll go into a little bit more detail on what Hayabusa is doing for us, as well as Plaso. So briefly, I want to pay a little bit of credit to the open source projects that we're leveraging here, right? Now, the Velociraptor extension has been around for some time in our platform, right? So most of you know we integrate very well. You can use LimaCharlie to run Velociraptor hunts on your endpoints. So huge thanks to the team behind Velociraptor for making that tool open source and available for everyone to consume and use. And now you know that you can leverage Velociraptor inside of LimaCharlie without requiring managing and hosting a Velociraptor server. So that's kind of cool, right? It's just the standalone agent and all of its capabilities are available to you. Now, another tool that we're going to be leveraging today is called Hayabusa. This comes from the team of Yamato Security out of Japan. Hayabusa is a very, very powerful event log processor. So when I run Hayabusa over a collection of event logs, what it's going to do is it's going to very quickly assess all of the event logs for the presence of one of the many thousands of Sigma threat detections, as well as many, many, many built-in detections that Hayabusa has itself. Now, let's talk really quickly about why that's cool. Remember, as I mentioned, once I deploy the EDR agent in an environment, great. I've got forward-looking visibility now. I've got threat detection rules already running in LimaCharlie. So that's wonderful. That's covered. But wouldn't it be nice to get retroactive detections of things that were occurring before the agent was installed? That's what we're talking about right now. By pulling all the event logs off that system, which we already did with Velociraptor here, we're going to now push those into Hayabusa and get retroactive threat detections on things that happened a week ago, a month ago, right? Now, obviously, that depends on how far back our event logs go, but keep in mind, no matter what you pull off that system, Hayabusa is going to have findings. It's going to have interesting detections. Now, the other and arguably most powerful tool we're going to introduce today is a tool called Plaso. Now, Plaso, also known as Log to Timeline, is a Python-based forensic artifact processing powerhouse. So to really just put it simply, you can basically process any type of forensic data you pull off an endpoint with Plaso. Doesn't matter what it is smart enough to understand the data that you aim it at and extract out whatever important metadata can be gleaned from those forensic artifacts. So I could just simply feed list prefetch files or registry hive or an amcache or whatever, forensic artifacts galore, right? And Plaso is going to run through it. It's going to extract out all the key important data, and it's going to build a forensic timeline. Very, very powerful tool. Now, The one catch, so I wouldn't call it a catch, but just the one big consideration about Plaso is that, yes, it's so incredibly powerful. However, it requires a lot of processing power to run it, right? So if I, spin up a system with 32 cores, then it's going to perform very well. Plaso is going to be very fast because it will use all 32 of those cores. If I'm running it on my MacBook, I might have a different experience, right? Now, again, the reason I bring that up is that we've abstracted away from you the worries, the challenges of having all this processing power available and ready to go, because it's all just running in our cloud now. So let me go back to my diagram and kind of remind you, now that you kind of know what Hayabusa can do, what Plaso can do, see now the value of being able to automatically run triage acquisitions, push those directly into Hayabusa, directly into Plaso, and just simply have ready to go analysis output pushed out on the other end, right? Really, really cool when you see it in action. So it's exactly what I want to show you now. I want to show you what this process might look like. So, kind of walk through it with me as if we are incident responders coming into an environment for the first time. Let me refresh my browser here. So we're coming into an environment. All we've done is we've deployed our LimaCharlie EDR agent, right? So now we have several systems here checking in. They're online. We've got full command and control capability. Telemetry is streaming in real time. So if there are active threats in the environment, our detection and response engine will find them. But once again, the main question I need to answer now as an incident responder is, okay, but what happened before I got here, right? What happened before I deployed this agent? So let me walk you through exactly what it might look like to answer those key questions. So the first thing I'm going to do is I'm going to come down here into extensions, and I'm going to drop into Velociraptor, because this is how I'm going to get those triage acquisitions. Now, what I've already done is I've labeled several systems in this environment as compromised. And I'll just show you that for posterity so you can kind of see. Notice I've got a handful of systems in here, and some of them have the label compromised applied to them. So I can just very easily add that label to any system that I want to do a deeper dive on. So I'm going to use that label here in a moment when I come over to Velociraptor. And I'm going to ask Velociraptor to help me perform a triage acquisition of these systems using the Windows Taped Files Targets artifact. Now, when I specify the sensor, what I'm going to simply do is say, hey, all sensors that have compromised in their tags. Simple as that. So it's now going to identify every system with compromised as a tag, and it's now going to target these in a triage acquisition. Now, let me remind you, everything you see me here doing on the screen is great and all, but at the end of this, I'm going to share some copy pastable step-by-step guides with you to be able to follow through and recreate this on your own. So don't worry too much about paying razor sharp attention to detail here. But okay, so I've keyed up my Velociraptor acquisition, and all I need to do now is click Collect Artifact. Now it's going to go through and it's going to identify which systems does it need to run this on. It noticed that there are only 2 systems that have that tag applied, and the hunt is now running. Excuse me. Now, one thing that I can do anytime I'm working with these extensions, if I want to kind of keep a real-time view of what's now happening in that extension, is I can come back to the sensors page and I can find the Velociraptor extension sensor, click into it, and I can go in here and I can watch the live feed basically. Like if I'm really just kind of anxiously waiting for this thing to get done so I can move on and do the next step, I could watch the live feed, or I could just simply come back and check the timeline for the sensor to see all of those actions that I've taken. And so what you're seeing here is, for instance, when I created a Velociraptor hunt for Windows Cape Files targets with the argument of Cape triage equals Y. And you can even see the sensor selector that I use here, compromised in tags. Now notice it's also showing me here the 2 sensor IDs that were targeted by this hunt because of the compromised tag, right? And now I can follow along and see, okay, here's each step in that process. It generated the artifact, it uploaded the artifact, and the Velociraptor collection was completed, right? And notice I got that from both of my sensors here. And if I wanted to, I could take a quick peek here in the output from Velociraptor to kind of see all the metadata of all the files that were acquired. But I'll be honest with you, I probably don't really need to do that because I can just go get the zip that was created. I can come right back here to the LimaCharlie artifacts page, and I can see right here this Velociraptor type artifact. It is that acquisition. So this 65 megabyte zip file is all the forensic data that it pulled off this system that it deemed noteworthy. I'm willing to bet you if I unzip that, it'll be several gigs. You'd be surprised how well these things compress. But needless to say, I don't even need to download this raw zip file full of forensic data. It's there for me if I need it. But remember, what we're going to do is we're going to let the SecOps Cloud Platform handle the processing for us, right? Now, let me show you how that magic works. I'm going to cruise over here into my detection and response rules. Now, these are not conventional detection and response rules, okay? These aren't looking for threats. Well, one of them is actually YARD detection and memory. But these other four, these are actually simple automation rules that are automating different things inside of LimaCharlie. So for instance, I'll show you one here that's going to be meaningful to us. So I've got a rule that simply says, hey, I want to send all Velociraptor acquisitions to Hayabusa. And so the detection block is simply looking for those Velociraptor exports being complete. It says, hey, watch for a Velociraptor collection. And once the export is complete, I want to send that collection now to the Hayabusa extension. I've got some specific request parameters that I can specify. For instance, hey, the minimum rule level that I want to fire on is informational, because Hayabusa can be filtered basically based on the severity of detection that you really care about. But I want them all, so informational is good. I can even specify what output profile. Now, just as a quick aside, these things are derived from the actual command line arguments of Hayabusa itself. So if you ever wanted to get under the hood and tweak and customize and tune this, you just simply would reference the LimaCharlie docs for the extension and or the tool docs itself to learn, well, what is, for instance, what is time sketch verbose, right? I could dig a little bit deeper into that. But I'll tell you right now, the defaults that you see here are spectacular. These are tuned in. These are very well thought out. And so the blog article that you can find on our website now is going to guide you to using exactly these same arguments and parameters. But so this detection and response rule has already done the work that I needed it to do. It has sent those Velociraptor acquisitions straight to Hayabusa. It has also sent them straight to Plaso. Now, one cool thing that I'll notate for you here. If you recall, Hayabusa is only really meant for processing event logs. But if you've been following me here, we pulled entire triage acquisitions off of those endpoints, not just event logs. We pulled registry, we pulled prefetch, we pulled all kinds of forensic goodness. But the thing is that the extension is smart enough to say, hey, look, you can send all of that stuff to me. I'm still just going to process the EVTX files. So you don't have to think too hard about how you accomplish this. The extension will sort it out. It's going to unzip that larger zip, and it's going to find the EVTX files within, and it's just going to process those. So it keeps the DNR logic much simpler. Now, same thing with VR to Plaso, right? It's going to take those Velociraptor acquisitions. It's going to send them straight to Plaso. And look how simple this extension request is, right? All it really needed to know was the log ID for the artifact, which is that zip file that was pulled by Velociraptor, and it's off to the races. So what I'm going to do here is I'm going to come back and show you the sensor timelines for Hayabusa as well as Plaso, right? Because this is where I can go and kind of see the progress, the activities that are unfolding within these extensions. So if I go look at the timeline for the Hayabusa extension, it is going to be very, very verbose, because one of the arguments that I specified when I sent those event logs to Hayabusa is I said, hey, I want you to return your own output back to your own timeline. So basically every single Hayabusa detection is now right here on this sensor's timeline. So for instance, if I clicked into one of these events, we can take a look and see what it's trying to say. It's saying, hey, look, there's this Hayabusa event for a log on, a log off, right? So nothing really exciting or interesting there. But if I were to kind of keep looking, I imagine we could probably find some interesting things in here. Suspicious time modification, right? Maybe some PowerShell engine activity, right? So a lot of these are going to be informational, but don't worry. this isn't actually where I'm going to spend most of my time looking at these results, because another thing that I asked Hayabusa to do, and just to show you so you can kind of see it as I say this, is I asked it to not only send its data to the timeline, but I also have another DNR rule that's watching that timeline for all of those Hayabusa events that meet the criteria of medium, high, or critical. And then it's going to send those to my LimaCharlie detections page, which is generally where we get our work done, right? That's where threats go. So if I go look at detections right now, here are all of the high, medium, and critical detections that Hayabusa identified across those two systems that I sent event logs for. So now it's way easier to see the things I probably care more about, right? I can look and see, ooh, suspicious service installed, right? Logs cleared, firewall rules being added. These are the things that were noteworthy because they kind of exceed that severity threshold. So much quicker, much easier. But folks, I want to remind you something. Each of these extensions, Hayabusa and Plaso, also uploaded their raw output to the artifacts page. So if you don't like this view, or if you don't like the timeline view, that's fine. You could simply come in here, download those CSVs, and look at them however you want to, right? Eric Zimmerman's Timeline Explorer, for instance. But okay, hold on. There's more. So we've now seen the really cool output we get from Hayabusa, where it generated all these great detections of historical activity on those systems, right? But let's go see what Plaso is able to do for us. So I'll come back here and we'll go find that extension Plaso, and we'll drive into its timeline and take a look around. Now, Plaso does not give me the option to send all of its output to the timeline because, folks, we're talking about millions of events. When you run even a triage acquisition on a system and you feed that into Plaso, expect hundreds of thousands, if not millions of rows of very, very granular timeline activity, right? This is a very powerful engine. So we don't choose to send it to the timeline because it would just be a massive data set. However, I'll show you what we do with it. So first of all, let me show you what is here in the timeline because it is useful. So you can see I've got a few job queues in here, job queued, as well as job started, right? So that just simply tells me that the Plaso extension received the request and it's now working on the data. And what I'm waiting for are these files or these lines here to show up. Plaso is simply the raw output from Plaso. Key info is a very important output for folks of you that are familiar with log to timeline or Plaso. Key info against the Plaso file gives me very important metadata about the processing that has occurred here. So it's basically summarizing for me, hey, here are all the parsers, whoops, excuse me, let me uncollapse that. It's saying here are all the parsers like amcache and appcompact cache and shell items, right? Here's all the parsers as well as the number of entries we found with each of these parsers. So for instance, the MFT parser extracted out, what is that? 3,255,000 items from the MFT, right? And the Windows event logs found 9,518 individual Windows event log entries, right? So this is a really great summary for me as an investigator to know, okay, what did it find in this evidence, right? What types of data is going to be available to me in the output? So I'm a huge fan of the pinfo timeline entry here because it kind of gives me some idea of what to expect when I dive into the much larger output that was just produced by Plaso. So we'll go take a look here back at our artifacts page because once again, this is where I can find those raw output files. Now notice, I really just want to highlight something really cool for a second. So if you come back to the original triage acquisition here, this was the simple get the evidence off the box that we did with Velociraptor. 65 megabytes worth of evidence, zipped, okay? It's compressed, but still, 65 megabytes. We sent that to Plaso, and that produced a 1.68 gigabyte timeline. So just think about the ratio there, right? Like with under 70 megabytes of evidence, I'm producing 1.7 gigabytes of forensic timeline analysis capability. Just shows you just how powerful and how granular this tool is. And folks, let me remind you, you didn't need to spin up any VMs or have any big, heavy 32 core systems on hand in order to accomplish this. It's all just handled inside the magic of the SecOps Cloud Platform. So if I wanted to spend some time digging into this timeline, I'd probably want to just go ahead and download it here from the platform, open it up in whatever CSV viewer that I choose. However, there are some other really cool options. Now, this is sort of an aside because this is not part of LimaCharlie, but if you do go down this route, if you do decide you want to use our platform in this way, and now you're looking at these massive timelines that you're ready to analyze, one of my favorite tools of choice for this activity is TimeSketch, another open source tool that you can pull down, spin up, and you can simply upload these CSV files that I was just showing you. You can upload the CSV file or the Plaso file. Either one will do. You upload it into TimeSketch, and now you have not only the ability to view timelines. Let me drop out and drop into a different one here really quick. You have not only the ability to view timelines, but you also have the ability to collaborate on these timelines with other analysts, right? So I uploaded all those CSVs, and now I've got each and every one of those timelines here all visible. It's very similar to kind of Elasticsearch. It is actually powered on the back end by OpenSearch. And now I can simply browse and view this timeline. I can star things, I can annotate things, and it's very highly collaborative. But again, this is not part of LimaCharlie. However, I will say that if you desire to use TimeSketch in your analysis, you can use the power of LimaCharlie to simply output automatically these CSVs right to your TimeSketch instance, right? So you could automate this thing from end to end. An analyst just simply walks up, pushes the button to start the triage acquisition, goes, gets a cup of coffee, comes back, timelines are ready to go. It doesn't get any cooler than that, right? So let me just kind of step through here and just show you one other kind of neat thing. So another cool thing that I can do is if I have other detection rules, for instance, looking for malicious activity in this environment, I can use those detection rules. Like for instance, let me show you, like if I have a yard detection on an endpoint in memory, which would be a pretty important detection, I could use that to automatically trigger a triage acquisition. So I could even automate the triage, right? This thing could be an entirely end-to-end automated process. But for most incident responders, they are very deliberate when deciding when and why to run a triage acquisition. So that's why I kind of took the approach of use the label, right? So I can simply slap a label on an endpoint and then use the label to target via the triage acquisition, and everything else is automated completely end to end. Now, let me show you how easily you can recreate everything you've just seen, right? And this is one of my favorite parts of the platform. So as I mentioned, right around the time this webinar started, a blog post went live on our website. So just go to limacharlie.io, go under resources, and click on our blog. And it's going to be the most recent post, obviously. And you can see here, automating incident response workflows with LimaCharlie. Now, there's some really cool high-level stuff in here that's going to be semi-redundant to the conversation we've had today. However, let me show you the new part. The new part is if you want to replicate this workflow exactly the way that you just saw me do it, all you've got to do is copy and paste this infrastructure as code template. It has everything in here. It will even enable the required extensions, such as the Plaso extension, Velociraptor, and Hayabusa, right? And then it will bring in those DNR rules that you saw me using that automate sending those event logs to Hayabusa, sending Velociraptor acquisitions to Plaso, and even the one that generates detection rules, or I'm sorry, generates detections based on the Hayabusa findings, right? All of it is here. So it's as simple as this, folks. Let me just show you because it's so easy. I think a lot of folks are surprised when they see just how easy this is. If you spun up a brand new organization, all you would have to do is come down here into organization settings, go into the infrastructure as code tab. We're going to apply a new config, paste it, hit apply, and your org is going to be identical to the one that I'm using right now. So then what do I do next, Eric? Well, if you recall, all I've got to do is run that Velociraptor acquisition using Kate Cape files, Cape files targets. And you can aim it at a single system or you can aim it at a tag. It's kind of whatever you choose. And then the arguments that I kind of prefer are Cape triage equals Y, because that's basically telling Velociraptor, I want to get all of the forensic artifacts that are identified in the Cape triage compound target. And just in case you're curious, like, what does that even mean? All of that is also open source. So if you go to the Cape files repository on GitHub and you go here and look under targets, look under compound, you can find in here Cape files. Let me just Control F and get down to where I'm looking for. Where are we at? Oh, I'm looking for Cape triage. Sorry. Doing it live. Okay, there it is. Cape triage. So basically, when you saw me type Cape triage equals Y, that's the equivalent of telling Velociraptor to acquire all of these evidence sources. And as you see here, this is a long list. And folks, let me also reiterate, each of these lists expands into other lists. So like, for instance, evidence of execution here is in this target, but evidence of execution is its own compound. So if I go look at evidence of execution right here, that expands to multiple additional items as well, like recent file cache, prefetch, app-get-pat, amp cache, and so on. So as you see, that one simple command line argument of Cape triage equals Y is basically telling it to collect hundreds of different forensic artifacts off that system, and we're going to send it seamlessly into Plaso for processing. So folks, that is the bulk of what I wanted to show you all today. I hope that's exciting. I hope that's something that kind of is able to be a game changer in your incident response workflows. If you have any questions at all, I would invite you to, first of all, we're right here in this webinar. I'm ready to chat with any of you that have any questions, but also feel free to join us in our public Slack at slack.limacharlie.io. Happy to geek out with any of you that want to talk about interesting ways to take this even further. That's all I've got for you today. Thank you for joining me. Also be sure to check out this new blog post. I'll go ahead and drop that in the chat here as well for anybody that wants to see. Oh, I see Charlton beat me to it. So yeah, you can see the link in chat if you want to check out the blog post. Otherwise, folks, have a great rest of your day, and we'll see you on the on Slack.